Okay, so let's determine the possible number of positive and negative real zeros of that polynomial. So, remember to find the positive, the number of positive real zeros. We're going to count the number of sign changes. Of f of x. Now, f of x is given in the problem. And I'm going to go ahead and rewrite it so I can mark on it if I need to, and I can still see it for when I do the next part. So they told me that f of positive x is equal to x to the fourth minus 14x cubed plus 71x squared minus 154x, oops, forgot my 4, plus 120. All right, so let's go through and let's look at each term. Tell me, is x to the fourth right here, is it positive or negative?
Positive.
What about this 14x cubed?
Negative.
Do you see how it went from positive to negative? That's a sign change. It's going to count. What about the 71x squared?
Positive.
It went from negative to positive. That's a sign change. We're going to count it. What about the 154x?
Negative.
Again, positive to negative. It's a sign change. And the 120.
Positive.
So negative to positive, sign change. So how many sign changes did we have there?
4.
All right, so there are 4 sign changes. So that means we're going to have 4, or, remember it says subtracted by an even integer, positive even integer, which means subtract 2. So what's 4 minus 2? 2, or subtract another positive even integer, so subtract another 2, and we get 0. Now remember, stop when you get to 0 or 1. So what this means is that we got 4 or 2 or 0 positive real zeros.
Where'd you get the 2 from?
Let me write this for just a second. So 4 or 2 or 0 positive real zeros. All right, so where did I get the 2 from?
Yes.
All right, because remember we have to subtract it by a positive even integer. My smallest positive even integer is 2. So right here, I took the 4 that I had just found and I subtracted it by 2 to get the 2 right here.
So do you always use 2?
Mm-hmm. And then you take that number and I subtracted 2 more right there to get this one.
Okay. Why
And
did you
then-
use 2?
Because it says to subtract by a positive even integer. And what's the smallest positive even integer that we know?
Always gonna be 2.
So it's always going to be 2, yes. All right, so what this means is I might have a positive real zero, but it's not a guarantee because I could have 0 of them, okay? So I might want to try positive, but I might want to try negative if I'm guaranteed a negative one. All right, so then we got to find the negative real zeros, the number of negative real zeros. So we're going to count the number of sign changes. Of f of negative x. So this time I'm going to have to do a little work. I got to go find f of negative x before I can actually count the sign changes. So f of negative x, I'm going to take my f of x as they gave me in the problem, and I'm just going to plug in negative x for every x. So I'm going to do my skeleton. And I'm going to plug in negative x. Now remember, when you plug in a negative number, if you raise it to an even exponent, it becomes positive, and a negative number raised to an odd exponent stays negative. So as I'm going through here then, I know that negative x to the fourth is a positive x to the fourth. Now my minus 14. And negative x cubed, that's an odd exponent, so it's going to stay negative x cubed. Plus 71. And negative x squared, that's even, so it's going to become positive x squared. Minus 154 times negative x plus 120. Alright, so when you completed the f of negative x, you got all positives. There's no sign changes, which means there's no negative real zeros for this one.